Hello everyone. Today I'll be presenting our cloud computing assignment project called LuxeGlow. LuxeGlow is an online e-commerce platform that specializes in selling cosmetics and skincare products to customers across Malaysia. The company offers a wide range of beauty and personal care products, including facial cleansers, serums, moisturizer, makeup sunscreen, skincare accessories from local and international brands. The objective of this project is to design and deploy a secure and scalable web services infrastructure using AWS Cloud Service. This implementation, we use AWS Academia Learner Lab to configure networking components, security settings, and a web server environment for LuxeGlow platform. I created a VPC to provide a secure network environment for the web application. The VPC was designed with 2 availability zones to improve reliability and availability. Next, I attach an internet gateway to enable internet connectivity for public resources. In addition, a NAT gateway was created to allow private subnet resources to access the internet securely without being directly exposed. I also configured separate route tables for public and private subnets. The public route table directs internet traffic through the internet gateway, while the private route table routes outbound traffic through the NAT gateway. A security group was implemented as a virtual firewall to control incoming traffic. We allowed HTTP traffic on port 80 for website access and SSH traffic on port 22 for a secure remote administration. I launched an Amazon EC2 instance to function as the web server for LuxeGlow. The instance was deployed in a public subnet and associated with the configured security group and lab role. Finally, we tested the deployment by accessing the EC2 public IP address through a web browser. The successful display of web page confirmed that the web server and networking configuration were functioning correctly.
I'm Chai-En and I'm responsible for Task 4 instance scaling and monitoring, and Task 5 storage expansion and backup. For Task 4, the first step is to enable termination protection. I enable termination protection for EC2 instance. This prevents accidental deletion of the instance, which is critical for production environment like our e-commerce platform. The next step is to upgrade instance type. To handle business growth, I upgraded the instance from T3 micro to T3 small. This doubles the memory from 1 GB to 2 GB. The process requires stopping the instance first, then upgrading, and finally start it again. After the upgrade, the web service is back online with a better performance. Step 3 is to configure CloudWatch monitoring. I created a custom CloudWatch dashboard to monitor CPU utilization, network inbound, and network outbound traffic. This metrics helps us detect performance bottlenecks. For example, during flash sales, we can see if CPU usage spikes and take action. Next, I also configured a CloudWatch alarm. I set up a CloudWatch alarm which is the high CPU alert. It triggers when CPU usage exceeds 80% for 2 consecutive periods. These alerts are operation teams to investigate or scale up before users are affected. Moving on to Task 5, the first step is to create new EBS volume and attach it to the EC2 instance. I created a 10 GB GP3 EBS volume and attached it to the EC2 instance as a secondary disk. This is a hot attachment, meaning the instance keeps running without any downtime. The next step is to connect to EC2 instance to configure file system. I connected to the EC2 instance using Session Manager. I ran lsblcare to confirm the new volume was detected. Then, I formatted it with the ext3 file system, creating a bulk point called mnt data and mount the volume. The df command confirms the volume is successfully mounted and ready to store data. To ensure the volume automatically remount after a reboot, I configured the etcfstab file. This makes the storage persistent across instance restart. And the final step is to create EBS snapshot for backup. I created an EBS snapshot as a backup. Snapshots are essential for disaster recovery. If something goes wrong, we can restore the volume from this snapshot or use it to deploy a new environment. That completes Task 4 and Task 5. With this configuration, Our e-commerce platform now has monitoring and alerting, the ability to scale vertically, and persistent storage with backup. Thank you.
My name is Zhixing Tan, and I was in charge of Task 6 and Task 7. For Task 6, I first created a custom DB subnet group. To ensure network isolation, I restricted this group to our private subnets spanning across two separate availability zones, US East 1A and US East 1B. Next, I configured the database security group. I created a single inbound rule allowing MySQL traffic on port 3306 only if it originates from our web server security group. For our DS instance, I deployed our database using the dev test template on a single AZ deployment, which gave us a fully functional database while saving our lab credits. For credentials, I set the master username to admin and came up with a password, which I then passed to our application backend for database integration. We also utilize a burstable dbt3 microinstance type to stay optimized within our lab budget. For storage, I allocated a standard 20 GB general purpose SSD. For connectivity, I attached our database to our custom VPC and disabled public access. Finally, for VPC security groups, I attached our custom RDS security group. I then handed off the RDS endpoint and credentials to my teammate Shahil to conduct the application integration and connection testing. Here's a video clip demonstrating our successful end-to-end database handshake.
Task 3 demonstrates the deployment of the LuxeGlow web app on AWS. First, I accessed the EC2 Linux instance and navigated to the Apache web server directory where the application files were hosted. After this, I verified the front-end files, back-end API services, and database resources required for deployment. After deployment, the LuxeGlow website was successfully hosted on the EC2 server and became accessible through the public IP address. I then integrated the application with AWS RDS, allowing dynamic product data to be retrieved successfully from the cloud database. Finally, I tested error handling and troubleshooting by identifying and resolving backend configuration issues such as HTTP 500 errors and API configuration problems. This completes the successful deployment and cloud integration of the LuxeGlow web application. Thank you.
Once our database connection was fully verified, I moved on to task 7. I first created an AMI, which we then used as a blueprint for scaling. Next, I created a target group using the HTTP protocol on port 80. I also registered our EC2 web server as the primary target in this group. Next, for the application load balancer, I mapped it across our public subnets in multiple availability zones. We added an HTTP listener on port 80 to catch all incoming user requests and route them directly to our target group. For our launch template, I selected our custom AMI, chose the T2 micro instance type, and configured the network settings to use our web security group. Critically, I attached the predefined IAM instance profile so that our Scout instances can securely talk to our database without hard-coded keys. Finally, for our auto-scaling group, I deployed our scaling instances within our custom VPC and restrict them to our private subnets across two availability zones to keep them hidden safely behind our load balancer. For group size, I defined our capacity boundaries with a minimum of 1 instance, a desired baseline of 2, and a maximum of 4 to handle heavy spikes. To automate this, I configured a target tracking scaling policy tied to CloudWatch. I then tested our application load balancer using its public DNS point. As you can see in this clip, the load balancer successfully receives incoming customer traffic and forwards it seamlessly to our backend web servers. And that marks the end of our video. Thank you.